We're solving limits numerically and graphically, and if we have time, I would love to get into algebraically section 1.3 just a little bit. That's my goal with it, okay? Numerically, what are the directions saying if it says evaluate numerically? Table. What are my settings right now that allow me to put in these values that are getting closer and closer and closer to my constant that x is equal to? My table settings.
Oh, ask.
Not auto. Auto goes by step increments. I don't want to do that. I need to make sure it's an ask, the independent variable. That way I can put in the x and get out the y. Why did I put, like, poor K, poor qua, how come? Why did I put 4, negative 4, sorry, in the answer yesterday? Because as you plug in, all the tables seem to be indicating that it was approaching negative 4. Now, what was the weird thing at this negative 1? We plugged in this function, so seemingly, if you plug in negative 1, you get out negative 4. Is that true? Not all the time. Let's look at this one. Is it true in this one? No. If I did plug in negative 1, just a quick exploration getting us ready for solving algebraically. If I was to plug in negative 1, f of negative 1 equals what? 0 over 0. And my kiddos from last year, whenever you see 0 over 0, I always want you to think, keep going. We'll get back to that when we get back into the algebraic process. But whenever you see 0 over 0, don't just get stuck at the over 0 and say, nothing, deity, does not exist. That's not necessarily true. In this one, technically, yes, there is a denominator of 0 at negative 1, but the limit does exist, and the limit is negative 4. Can anyone tell me the reason why? Thinking about graphs. Why, even though function does not exist at negative 1, the limit does exist?
I think there's probably
Not an asymptote. A hole. So there's a discontinuity, there's probably a hole. And with that hole, where are we approaching negative 1? Is that right?
Oh, yeah.
And it's a parabola on top of a linear, which means overall it's a linear if we did synthetic division. So some sort of line, some sort of positive line coming in towards negative 1, negative 4. My slopes are probably going to be a little bit off. 1, 2, 3, 4. I have a line and somehow it's coming in. It's coming in towards the hole. So, does the function exist?
Oh, no.
But does the approach exist?
Yeah.
Yes. And where? And if you watch those videos from the summer, right? The diners, the two guys headed to a diner, are the two guys headed to the same diner? Yes. And where are they headed? Negative 4. There are a couple different ways of illustrating. I forget the way that he specifically did. You could say something, if there's a hole, you could say something like, the diner burnt down. So they're headed, and they meet there. It just burned down. And they're like, aw, wah, wah, wah. But they're there. Like, they met. They just can't go into the diner because it's not there. But they met, right? The other way of thinking about it is they got all the way there, they got up to the diner, and they went, and it was locked, it was closed. It was one of those like little private ones. They're like, oh, family holiday. Anyway, they couldn't get in the diner, but they're there. Does that make sense? Like, that's what's going on here. This hole is infinitesimally small. Because if you think about negative 1, at negative 0.9, there is a point, just not at negative 1. And at negative 1.001, there's a point, just not at negative 1. Does that make sense? So this little gap is infinitesimally small. And so what we say in calculus is the limit, what they are approaching, does exist. It is negative 4, even though the point does not. Super important concept in the sense of super common mistake kids make, especially when they see a graph. Kiddos, I want you to go ahead and use your table. Reorient it, meaning changing up the function, changing up what x is approaching. And I want you, using your table, to go ahead and find this answer. And it might be nice because this one, you guys don't algebraically actually know how to find unless you know a certain formula or you know something else which needs derivatives. So, this one, in a sense, without guessing, you don't truly have another way of solving it without it. Down here. Go to your calculator. See what you have. Yes, calculus, always radians. Always radians. Unless you need to reference degrees, but then you better change the answer back to radians. Always. So hopefully you guys in your calculator got, do you guys remember how to make this snazzy fraction thingy appear? Good. Alpha y equals and enter. Alpha y equals and enter in the newer calculators. If your calculator has a yellow second button, sadly that shortcut won't work. You should just use parentheses instead. Give sine of 3x. Once again, only in the updated calculator. Sadly, the old ones have an older operating system that won't work. You should have in your table settings ask selected. That's the most important part. You might have old values in there like I did. I have to delete all of those because what am I approaching this time? So how did you approach? 0 from below. Yeah, I could do negative 0.1, negative 0.01, negative 0.001, right? Put it down negative 0.0001. How would you approach from the other direction? Ooh, what's the E mean? Scientific notation, good. It shows times 10 to the power of negative 4. So I can do 0.0001. Positive will be the other side, 0.001. 0.01. You guys can probably tell what's going on, yeah? It actually hits 3? Nope, but it gets closer and closer and closer. Well, then from the other direction, right? From this direction, it gets closer and closer to 3. Coming from above, it gets closer and closer to 3. Does that make sense, kiddos? Okay, so then as a result, if that's true, let me go and put that right there. We can go ahead and say, yeah. So we can go ahead and say the limit does exist, the limit is 3. Question, real quick, just getting ready for algebraic, since you guys did some of this summer. If you were to plug in, what would f of 0 actually equal?
Sine of 0.
Good, sine of 0 over 0. Come on, think straight. What is sine of 0?
Is it 1?
A sine curve starts in the middle. Sine of 0 is 0. Remember, sine is opposite, sine is the y, and that's 0. The x is 1 and the y is 0.
Oh, so you 0 and 0 keep going.
Oh, sorry, I did not read that then. I meant to write 2 zeros. There we go. Which means keep going. Now, in this one, you might not realize how to keep going. The last one, some of you were like, oh yeah, factor and cancel out and we're good. This one, you're like, there's trig. We'll talk about that one when it comes to the algebraic part. Let's keep on going. We were able to find it with the table. Graphically, use what we've been talking about. Get down the notes. It is so important because kids do so easily forget what a limit is, the approach, not the act. So let's fill in and then make a quick sketch of the graph. And write from the graph, once you get there, write the problem of the example it is illustrating along with the answer. Does that make sense? When you get to the graph, write the problem the illustration is showing. The problem that's being illustrated. Write the problem and the answer. Write the problem and the answer after you get there. Did anybody fill out the fill in the blank? If we're trying to answer a limit problem graphically, we're approaching from the right and left of an x value, but for the answer, we are looking at the
What?
good. The x tells us how to approach, but the answer comes from the y value. So we're thinking about y values is thinking about the heights. Look at the heights of the function. Look at the y values, look at the heights. So then as you look down at the example down below, what problem is being illustrated, guys? The limit as x approaches 1, I totally agree. The limit as x approaches 1. Do we know exactly who that function is? No, so we're just going to call him what? Yeah, he's a function. Good, we're just going to call him f of x. But even though we don't know the function, we can, using the graph, go ahead and say, well, look to the heights. What is the limit? 2. Does it matter that there's a hole for the limit to exist? No. Is the function continuous at 1? No. There is a discontinuity. But the limit does exist. The approach does exist. Any questions on that? Does that make sense? Or the little arrows signify? Yeah. So as x approaches 1 from below and from above, we're looking to the heights at those points. So as x approaches, we're looking to the heights and the same what are the y's approaching. And the y's would be the direction I'm approaching to, which you would see in the table, but you can also see in the graph. Is that okay? So when the limit's not exist, you can say where the limit's not existent, the limit's dne do not exist, the limit dne does not exist. The nice thing is, so far, these notes are pretty much the same that we took last year. At least in my pre-calc. Mr. Trey usually kind of uses my notes. I'm going to go ahead and mark a few things down here just for sake of illustration. Okay. So what we're talking about for each of these is that the limit as x approaches a of f of x. So a is the constant that x is going to be approaching. You can call it c sometimes, you can call it a, it's just a constant. So I'm going to go ahead and mark an arbitrary a. I'm just going to randomly put it over here on the right. I could have put it on the left, but it did have to be an x value. So I'm just saying that's the place that x is approaching. I'm going to give a few illustrations of f of x that would show what is going on with each of these different cases. Okay, so for A and C, for the first and last case, the limits truly do not exist. The limit truly does not exist. The limit as x approaches A, remember we're doing the limit as x approaches A for every single one. We want to actually go ahead and write it for each and solve it for each. Okay. Question. Do the one-sided limits agree? Are the drivers meeting at the diner? At one place? At one diner?
No, they're going to be
Nope.
separate diners.
Yeah, do you remember my kids from last year? Do you remember how I illustrated what might be going on here?
Taking a wrong turn.
Not a wrong turn. They both went to their destinations.
One of them gave the wrong directions.
One of them didn't check Yelp and figure out that the old location closed down. There's a new location. The other one did, right?
So one of them.
This one went to the old location. It wasn't there. It was closed down. The sign was down. All the stuff was out, and there was a new sign saying, "Hey, the new location is." And this guy went there, and there is the diner, right? You can kind of think of it that way. It's a silly way of thinking about it. They're both headed somewhere. Just one, it didn't work out, and the other one it did. But they definitely didn't meet the first time. The guy had to redirect, right? So therefore we say the limit does not exist. If the one-sided limits do not agree, if the two guys don't meet, the limit does not exist. That's the final answer. We're done. Letter B. The limit technically, look at the technicality down below, the limit technically doesn't exist because are the functions headed to a constant? No, where are they headed? Now, do they agree on the approach to infinity? Yes, so I can still express the answer, and I do still express the answer, and the AP guys express an answer, but we would say that it's a technicality. It technically is not an actual limit, because an actual limit is talking about a constant, but we can still express where the function is approaching, and since both sides agree, the guy coming from the right and the guy coming from the left, since they both agree, I can go ahead and say the limit, in a sense, is still able to be expressed, and so we say infinity instead of a constant. Okay, so letter A, we say DNE every single time. Letter B, as long as it's a two-sided limit, there is no little plus or minus. Letter B, we say nope, it's infinity because they agree. Now question, what if it was one of those where the infinities did not agree? Look to case A, it does not exist, right? So if the vertical asymptote, if you're going two different directions as you come in, yeah, no, look to part A. The limit does not exist. Part C is a little hard for you guys to think about. I'm going to tell you that if a graph oscillates between two fixed values as you come in towards, as x approaches A, as you come in towards that constant x is supposed to be approaching. Once again, the limit does not exist. But this was kind of hard to see, so let you guys really quickly get an example function in your calculator. It's not this one exactly, but it's similar. I want you to put in to y equals sine of 1 over x. I want you to put in sine of 1 over x. And I want you to see, graphically or numerically, what you think the limit is if x approaches 0. I will give you a hint as to how to do it algebraically. There is a way of thinking about it that makes a little more sense maybe. But the graph is good to see too, just in case you ever come across one like this. Sine of 1 over x. As x goes to 0. If you zoom in and zoom in and zoom in and zoom in, it's going to keep looking more and more and more and more like a barcode. It's weird. Because right now it's like, oh, it doesn't look that bad. It's probably like approaching 0 or something, right? So then you're like, okay, just zoom in, go. And you're like, okay, no big deal. Like, okay, yeah, it's approaching 0. Like, I totally get this. Now, we could go ahead and on the graph, we could hit trace or second trace value. Type in 0 and say, what's going on at 0? Uh-oh, it's undefined. Why? Yeah, there's nothing there. And the reason is algebraically, what would happen if you plugged in? What is f of 0? What is sine of 1 over 0?
Oh, undefined. Oh, shoot, isn't that?
Last that in a second, but it definitely doesn't work, right? We'll get back to whether or not that's a keep going in just a second, because right now most of you would still say the limit is 0 because it gets closer and closer and closer to what seems to be 0. But what happened when you zoomed in again? Uh-oh, wait, now this is going up and that's going down? That's even worse. What happens if you zoom in again?
Oh no, keep going, Misty. Oh no.
Now it's not even like it's totally freaking out, right? What if you try to trace and say, okay, what's going on at 0.01? Okay, it's at negative 0.5. What's happening at negative 0.005? Now it's at 0.8. What's if it's negative 0.00009? Now it's at negative 0.6? What is this thing doing? It's oscillating. It's bouncing back and forth and back and forth and back and forth. Guys, can we think about the algebra for a second? 1 over 0. We haven't specifically reviewed it, I don't think, yet. But does anybody remember what a number over 0 seems to indicate? It is undefined, but it's not a whole. It's not indeterminate form. So it indicates an asymptote, a 0 in the denominator with a number up top, so the zeros can't factor. It can't be removed. It's not removable. Makes you think of an asymptote, and an asymptote makes you think of infinity as far as limits are concerned. So this would indicate infinity, either positive or negative, or maybe bouncing back and forth between positive and negative. Question. What does sine do as you go to infinity? Does it ever get closer and closer to anything?
No.
What's it do?
The same thing over
It
and
keeps
over.
oscillating, right? Does it make sense that you're just taking sine in bigger and bigger and bigger numbers, or more negative, more negative, more negative, more negative, more negative numbers? It's never going to approach 1 constant. So algebraically, it makes sense too. Either way you look at it, the limit does not exist because the function is not approaching a single constant. It doesn't work. Anyway, that's another D&D case that isn't specifically able to be seen like this one. So we make it its own little case. The graphs are getting excited. So we talked about two-sided limits. If you see the limit as x approaches c, the limit as x approaches 1, the limit as x approaches 0, you have to consider both sides. And we did that in the last few examples. We've had to consider both sides. And if the limit coming from both sides, or I should say either side, if the limits do not agree, the limit does not exist. The limit does not exist when the one-sided limits do not agree. So we're going to talk about the one-sided limits. How do you split this up and talk about it piece by piece? Because in math we show work, right? And part of showing work for limits is saying, well, I have to consider the piece below, and I have to consider the piece above, I have to consider the driver coming from the left and the driver coming from the right, thinking of the illustration. And so mathematically, they made a way of talking about coming from below or coming from the left. And to come from the left, they say, show a with a little minus, good, in the exponent. It means a, but a little bit less. It's not an actual exponent. It's not being raised to an actual power. But when you have the limit as x approaches a with a little minus, that means you're coming from numbers that are a little bit less than a, aka a little bit on the left of a, aka below a. If you have a with a positive little exponent, numbers a little bit bigger than a. Numbers above a, coming from the right of a. So, basically, this is a way to show work. And it gives us a way to break down a problem. Wow. That's really neat. Keeping you awake. That's what parents said last night. We like it. It keeps me awake. But I like it too, but I do with my sweater on. You want to start bringing the sweater? I do with my $2 jeans on. You guys okay if I zoom in on the nasty example?
There you go.
You have the top part okay? Now, if you don't like sketching stuff, could you theoretically get a nice little printer at home? Just go online, print it out, cut it out, put it in your notes.
Sure.
That's too much.
You can just print
That's not a bad idea. Just get a glue stick. Or, if you were to need to graph this and sketch this really quickly, how could you do it? What do you think I do whenever I'm trying to sketch something? Like, you have to do this in your homework, right? Because you have to sketch the problems, like the directions.
Putting numbers.
Round?
simplify it to like 2s or something. Yeah.
I was thinking just figure out the important points. What are the important points? Someone tell me an important point or a lack thereof.
Negative 4, comma 9.
I have -4. I have -8. I have 3. I have 6. I have 9. I don't know if we can go by 2s. We can try to go by 2s.
Yeah, just kind of.
-2, -4, -6, -8, -10. I have 2, I have 4, I have 6, I have 8, I have 10. Okay, I have -4, and what's my height at -4?
Oh, wait, I can't.
There are multiple heights.
No. What's my height? My intended height. Ooh, that's a snazzy math way of putting it.
9.
Intended height at -4? 9. Oh, good call. Never mind. What's the intended height at -8? 1? What's the intended height at -4 from below?
4.
4? What's the intended height of -4 from above?
9. This is disgusting. 9.
6 and then 9.
There's a
That's true. Good job.
point exists at 9. The point
But
exists at 6, but the limit
what's
is
the
approaching
intended height from above?
9.
9. What's the actual height at -8? See, the actual height is 6. The intended height from above is 9. The intended height from below is 4.
Yeah.
See it? What's the intercept approximately?
Ooh, what's -8?
You said -8.
Oh, did I say negative? I apologize. The actual height is 6 at -4. I was saying -8. I apologize. At -4. The intended height from below is 4. Intended height from above is 9. The actual height is 6. What's the intercept? Is it 0, 4?
Yeah.
So it's like some sort of swoopy swoop.
Yeah.
Then what's it
More
do?
of a-
Minimum of
Swoops,
a little bit after 1, a little bit below 2.
At 3,
3, 3.
point.
Is it an intended height or an actual height? Intended height or actual height?
Intended height.
Intended height. What am I saying when I say intended height?
It's not actually there.
It's not actually there. And then my intended height at 9 is -3. I think that's linear, right?
Yeah.
Okay. The one thing I probably would have changed is this shouldn't probably go up. It should probably just go down too. But otherwise, there we go. Anyway, can help you guys with sketching. Look for the important points. And think a hole is an intended height. Oh yeah, it's where it's intending, where the driver's intending to go. That might help too with limits. That's where they're approaching it, where they're intending to go. So looking at -4, what would you guys answer from what we just did in order to get the graph, what we just had to think about? What would you say the limit of x approaches -4 from below is? 4, exactly. It's the intended destination as you come from below, the intended height. The limit as x approaches -4 from above? 9. Good, the intended height, where the hole is. The limit as x approaches -4, you guys already said it. What's going on?
6.
No, it does not exist.
Why?
-4 in general doesn't exist.
Because when you approach them both ways,
The limit does not exist. The actual height is 6. So if I did have a separate question, we could make it, I don't know, something like letter F. If I did make f of -4, what would f of -4 be? 6. That's the actual height. But the limit as x approaches -4, nope, they're headed 2 different places. Is there one intended height from both directions? No. The limit does not exist. What's the limit as x approaches 0?
4.
Yes. Even though there are no circles, it's a normal one. As you come from both directions, the intended height is where they end up meeting, which is at 4. They get to go in, sit down, have breakfast. That sounds good right now. The limit as x approaches 3. Really? Yes.
What?
Yes. Because both guys are headed to the same one. Now are they going to get in and sit down and have breakfast?
No.
No.
You just,
Something's wrong. They burned down or they closed and had a family holiday. But they meet. They're both like right there, hands on the separate doors trying to get in. It's just, they can't get in. Okay? Limits, numerically, graphically, how's it going? So then, you, ready, set, on your own, go. Pretend it's a pop quiz. Pretend it's a pop quiz. Go.
Okay, how long do we have to copy down the graph, or do you just want to write the answers
Copy
first
down the
and
graph. And I'll give you the
Oh.
answers.
But do the answers first and then copy down the graph? Because copy down the graph might take a lot longer. Okay.
Can I just kind of estimate the graph quickly? Will I get credit?
As long as you label the important points, like when x is -4, -14,
Wait, I was going to 2 seconds. Wait, I was going to
0, 2, and 10. Oh, it is going by ones. Link those.
Yes.
Missed that. I got to go by 2. 9, right?
It's like a weird
There you go. I gave you the important points. You guys already know 0. You have -9, you have -4, you have 0, 2, and 6. As long as you have those with the correct. heights. The nice thing is in your homework, just like in your notes, if you make the graph, you're probably already identifying the answers you're about to write in, right?
Yes.
Thinking about the heights and the x's and how they correspond. Is it tedious? Yes, but after you write it down, do you know how to practice problem and study them? Without having to pull up my exam. If you have answers to each one, mark them in your notes. Just do a little thumbs up rest on your desk so you can see. You guys have chosen one. I want you to think on the AP if there were 4 different questions, which there aren't usually. If there were 4 different questions about this one graph, and it was those 4 that were stated, I want you to think which one nationwide would be the most commonly missed.
B.
Either B or
I did B or D, man.
Either A, B, C, or D.
C, you can make like a guess. It's probably two. C, I'm gonna say
Honestly, it would probably be C.
C.
Wait until 15. So we can check. Most
People
commonly
say-
missed
people
would be
say
C.
1. People say 1.
Most commonly missed would be C.
I got it.
What do you guys have for A?
-4.
At -6, the intended height, where it's approaching is the actual height, and it's 4. As x approaches -4, CNE. Most top students by the end of the year in the AP recognize that break means the limit does not exist. Most, not everyone. Most. Letter C.
2.
Not where the new location is, but where they are meeting. The intended destination, where they are headed, is to. Good. Letter D. If you don't see anything else, you assume it's headed in the same direction. It's linear by nature, so therefore, what's different? The limit as x goes to infinity. Am I zeroing in from above and below on infinity? No, maybe God can, but we can't. Why? If we're going to infinity, where are we headed?
all the way.
That direction. Positive infinity. If we were going to negative infinity, where would we be going? So we can only go one way. We can only go one direction. So, anyway. So, as I go to infinity, right, as x goes to the right, and to the right, and to the right, and to the right, to the right, what are the y's doing? So the limit would be, how do we express it? We would express it as positive infinity. If you don't show a sign, it is assumed to be positive. We would express it as positive infinity. Does the limit technically exist? No, but that will never be a question.
What if is limit x to negative?
Then where would our y's be going? In this example, it'd be going negative. Because it'd be going to the left. Pause. Is this page super crazy and hard?
No.
How would you guys fill in the answers right now without even writing anything?
Does not exist. Does not exist. Infinity does not exist.
Positive infinity. What's this one?
Approaches
Y does not exist.
because they're going opposite
They're
directions.
going in opposite directions. Remember, if the limits do not agree, the limit does not exist.
Negative.
Good. Ready, set, get down what you need.
Oh my, wait, what if I don't need anything?
How about we show sketches? Don't necessarily have to find the following limits. If I do quick sketches so you know the limit is infinity, does not exist, and is negative infinity. Hi, Mrs. D. Okay. Have a good week. You can keep like video or notes to give the last comment. Thanks. Good job, kiddos. We're right there. We got this. Give me an. I'm excited it's Friday. Smile when you're ready. What else fun? That's what you guys are just thinking about. It's like $4, $5. It's not really a fundraiser either. Whenever you see lunches and breakfast, it's almost always just chemicals. Just for you guys to know that they're not. Do they not announce that when they talk about it?
How much more?
Wait, pause. We're almost there. Hold on. Wait, we have one more little part of it. If pause as x approaches a from either side, if the limit is infinity or negative infinity, from either side, if there's an infinity, there is a vertical asymptote at a. And remember, vertical asymptote happens when you have a number over 0. We're going to talk about that in section 1.2.
Oh, shoot, I
Done.
didn't bring my dump.
Dun. Guys, work on homework over the weekend. Come Monday with questions and having it fully attempted. Bye.
I think I probably will do.
I think you should.